certain location for a certain storm period. For example, if we are looking into a hourly precipitation or hourly rainfall, so what is the highest probable value that can occur in a certain location? Okay, so this becomes so it is really important to understand this and estimate these reliable extreme values, probability and intensity, as I said, particularly for flood structures, designs and management. So from this we can better determine or we can conduct risk assessments in this changing climate due to this global warming. So when we say about risk, so we have a component of hazard and also the vulnerability, exposure, sensitivity. So in this case, it's the hazard part for risk. So particularly for extreme values for rainfall. So usually the most common is we do this frequency analysis, estimate the quantiles, which is based on the probabilities, and then we translate it into return periods values. So let's say we want to design a drainage. So how big is that drainage? What is the dimension? What is the depth? What is the width? So we want to design that. So we usually look into how much return period that we want to design. For example, 100 year or 50 year. It means that if it's 100 year, the structure we might expect it to be overflow or does not meet the capacity of that structure in that certain of return period. And so for engineer, this is really a big input to the design. Okay, and the other thing is which some might not realize this, probable maximum precipitation. So this PMP is also used as measurements for design, and especially for critical structures. I mean critical structures, for example, dams, emergency spillways, so like big structures. Anyway, maybe just introduction on what is frequency analysis actually. So it is actually a probability analysis. For example, we always do this PDF. For example, if we are looking into rainfall, so from the data observation that we have, so we fit it into let's say like a model. So we look into the probability of a certain values. So this is how we estimate a return period from probability density function and then to a cumulative distribution function. And then from this probability data analysis, that way we can find what is the expected estimates of a certain return period. So this is the common method which are used to estimate the return period. The other way is, for example, before frequency analysis highly depends on how much data we have, how long observation of data that we have. So it is very dependent on the data availability or our data limitation. Okay, so what about PMP? So PMP is if we have data, a long historical data. For example, I use here is a Japanese case because they have a really long data, more than 100 years of data. So PMP is actually we don't know which is PMP, whether that rainfall event has occurred or not. So we don't know. So it might be the highest point here. For example, in this location, Hikone here, there is this really extreme values event, which is really far from other data. So this might be PMP, so we don't know. And if you relate the PMP, probable maximum precipitation, with the frequency distribution, So PNP would be like the furthest value, the limitation, the upper boundary of the this frequency distribution. Okay, so for the first case study is using data from the Japanese, because they have a lot of data and hundreds of years. So this is suitable and opportunity to test methods, especially using statistical methods to estimate whether a method is better by comparing short observation data with long observation data. Okay, so for PNP, just like downscaling or GCM downscaling, it has statistical and it has also dynamical. So same to PNP, it has statistical method and also more dynamical or physical or hydrometeorological method. And however, for the hydrometeorological method, it requires more data, more variables in order to do the calculations. So it is quite difficult to be implemented and really when reliable and sufficient meteorological data are very limited. So that's why we can look into the statistical method. So for Malaysia, although we have a lot of stations, however, when we check the quality of the data, missing errors, whether it's long series, so we only have actually 179 stations when we check all the data. Okay, I think I've mentioned this. So in this way, because of the data, we may look into a regional analysis where we can test this to improve the statistical PNP estimation to compensate for data limitation. So this research is looking into that, to consider a homogeneous regions, which is homogeneous regions is a region where this rainfall data is being proved that it belongs to the same population. It has similar behaviors. So we may adopt this concept of homogeneous, original, instead of just using like a one station data. So for example, if we say homogeneous region, so we may identify which station is having a similar pattern or distribution or behaviors. So for the PNP, I will make it short. So for PNP, what we did is we used the conventional method, which is using a long data observation, and we compared what if we use a long data and short data observation, and then we use the new approach, which we introduced the homogeneous region concept into the PNP statistical estimates, but using shorter data observation. So if we see, if we use the conventional method, green is long data observation, black is short data observation, and so we can see that there is really a difference in the estimates of the PNP. So remember that PNP is the most highest probable rainfall that can occur. So if we use short data observation, we can see that it's not that high compared to if we consider the whole data that is available. So in this case, we might underestimate the PNP value if we don't have long data. If we have short data, we don't have the limitation in data, so we will underestimate the PNP values. However, if we do the new approach, however, using the short data observation, you can see that we can actually capture what we missed, the data that we don't have. However, we consider the concept of homogeneous, use the station which have similar behavior of the rainfall, we can actually capture the limitation Instead of, because we don't have long data, but we use short, but we apply a method which is considered the homogeneous, so we can capture the extreme values there. Okay, so as a summary, the PNP estimate based on regional approach are comparable to PNPs estimated using long observation records. Okay, so this is, I think, the same thing. So for example, for Malaysia, we also did the same thing as in the Japan, which have long data records. So to cut short, so the same thing that we did for Malaysia, we utilize the concept of regional frequency analysis. So in the end, okay, so this is very important for applications, especially for design, and if we have limited data. So that's all for my presentation. Thank you.
Thank you, Eliza, to highlight the need to have a more station.